Okay, fundamental triangle for a function on a given x interval. Well, let's do the function didn't write that very well. Basic reciprocal function on the interval one-third 2. Okay, so we draw the basic reciprocal function, draw the graph. Now, I'm not going to draw the entire graph. I want to have some room here. I'm just going to draw the graph in the first quadrant, because as you'll see, that's all we need. I'm going to do that until I did this. And this is 1/2. And 1/3 is about here. Okay, so here's 1/3. That means 1, 2, 3 of these should make up 1. I've actually got it a little too far to the right. And here's 2, and here's our interval. Now again, you have to understand interval notation. But this is the interval 1/3 2. Now the graph of the function, we go up to 2 here. See, 1 will be, yeah, it's a little high here, and 1/2 will be about here. So we have 1/2 2 because that's one of our basic points, and 1 1, and 2 1/2, so that our graph looks kind of like this. Okay, now actually I've leveled that graph off too much. It's not that level. Okay, that's a little better. Okay, 1/3. We project from the point where x equals 1/3 up to the graph to find the value of the function. Now, we know what the function is. It's 1 over x, and we know that 1 over 1/3 is 3, so the accurate value is 3, but we're going to base it on the graph. We're going to have to extend this kind of like out to the complete basic function and see if I extended it very well, because I'm going to do this by an estimate. Okay, so that this projection up here and over here, my estimate is that that's 1. This is about 2.5. Now I know that's not accurate, but that's what we're going to do. We're going to do it based on the graph. We're going to do it based on an estimate. So we estimate one-third 2.5, and my hand's used to making 2 kinds of brackets, or parentheses and brackets, and I kind of made the wrong one there. Okay, so point is ordered pair 1/3 2.5. Maybe you can't read that. It says not a very accurate estimate. Now the reason I'm using an estimate here is because, especially for the exponential function, if I don't give you one of the basic points, you're going to have to use estimates. And if I just give you a graph with just labeled axes and so forth, and ask you to do the fundamental triangle, you're going to have to use estimates. You're going to have to learn to estimate And in the process, you learn a little bit more about what a graph is telling you. Okay, so anyhow, we estimate this point. So right here is one point, right here is the other. When you do a fundamental triangle for an interval, you use the points at the ends of the interval. Point at the left end, the point at the right end, and the point on the graph that corresponds to the left end, the point on the graph that corresponds to the right end. I draw a straight line. And then I'm going to do my vertical side here, my horizontal side here. There's my triangle. I choose a direction. And you're free to choose the opposite direction as long as you're consistent, as long as the directions you choose get you from this point to this point, no matter what path you take, it's not going to matter much. It's not going to matter at all. You're going to get the same result either way. You can verify that. Okay, so I get my rise, I get my run. So my rise equals delta y from here to here. So I subtract where I start from where I end, and I get one half minus 2.5. Well, one half is 0.5, 2.5 is 2.5. That's minus 2. My rise is negative 2. My run is where I end minus where I start. 2 minus 1/3, which is 1 2/3. I'll write that as 5/3. Now I don't have room to write the words for my slope over here, the calculations for my slope, but I'll do it here. Also, I've got to be careful, and I wasn't, about saying that delta y is approximately equal to this, because it's approximate because I'm using an estimate here. Okay, so the slope rise over run, which is delta y over delta x. And we want to keep writing this out to reinforce it, to make sure we think about what we're doing and understand what we're doing. Okay, rise is delta y over delta x, which is going to be negative 2 divided by 5/3, which is negative 2 times 3/5, which is negative 6 over 5, which is negative 1.2. Okay, it's okay to leave it as a fraction, but since this fraction evaluates exactly as a decimal, it's convenient to do that. Now, where's the approximation? These aren't all equals, because the slope of the fundamental triangle for this interval for this function is not actually this. Again, since we based this number on an estimate. Well, the approximation occurs here where we use the number negative 2 that we got using the negative 2.5. In other words, there's where the approximation comes in. Okay, so slope is negative 1.2. According to our best approximation, at least this isn't a great approximation, but according to this approximation, the slope is negative 1.2. And there's our fundamental triangle for the function on the interval.